All right, so this video is going to go over pages 20 through 22 in your homework. I'm probably going to try to do this relatively quicker. So if at any point you want to pause it and try a problem and then see if we match up, that'd be probably the most ideal situation. So we're going to go and get started. A cannonball is fired with a velocity of 100 meters per second at 25 degrees above the horizontal. So I'm going to kind of draw this out. So we're not going to really grade you on drawing stuff. It's just you need to make sure you can plug things where they should go. Okay, so anytime I give you an angle with a magnitude, that means that's the hypotenuse. That means that 100 meters per second is 25 degrees off the ground. Okay, so that 100 is your hypotenuse. So it says, how far away does it land on level ground? So there's only two types of distances I can ask for, either how high or how far. Okay, so if it doesn't mention height at all, that means you're looking for your horizontal distance. That'd be your dx. Now, before I even worry about that, when I do these problems, I do the same 3 steps every single time. Okay, no matter what, I'm going to find my Vx, find your Vyi, and then find your total time. So remember, Vx, that's your adjacent side of your triangle, and Vyi is going to be your opposite side. So if you want to find Vx, all you got to do is take that hypotenuse, so 100, times cosine, so remember cosine uses adjacent, of 25 degrees. Again, make sure you're in degree mode. So 90.63 meters per second. So all you gotta do is literally type it in like that in the calculator. Just type in 100 cosine 25. Okay, then Vyi is gonna be 100 times sine, because that is, sine helps you find the opposite of 25. And you're gonna get 42.26 meters per second. So got those velocities. So once I break those into 2 pieces, I will never use that 100 again. Okay, so that thing's gone. So just whenever you break it down into Vx and Vy, just go ahead and mark it off. It's already done. Okay, now total time. So T total, remember we'll give you this equation. It's Vyi divided by 4.9. You're going to take that 42.26, divide it by 4.9, and you get 8.62 seconds. Now that is the total time. That is from launch all the way to the top and all the way back down. And that's called your hang time. So remember, we're looking for dx, okay, horizontal distance. Remember, the only 3 things we care about horizontally is Vx, dx, and t. Okay, dx is what we're looking for. Vx we just found, so make sure you're using the right velocity, 90.63. And your time we just found, that is 8.62. Okay, so remember Vx equals dx over t. So 90.63 equals dx over 8.62. So multiply both sides by 8.62. And you get a horizontal distance of 781.23 meters. If a baseball player throws a ball at 35 meters per second, was the maximum range. So I gave you a value, but I didn't give you an angle. But my dead giveaway that your angle is going to be 45 degrees, as I mentioned, maximum range. So that is the best angle for maximum range. So my triangle would look like this. So 45 degrees. My hypotenuse is 35.0. So we're going to break that into our Vx and Vyi. So I'm not even going to see what it's asking for yet. Okay, well, it's asking for maximum range, but I'm going to go ahead and do this every time. So Vx equals 35.0 times cosine of 45. And you're going to get 24.75 meters per second. Vyi is 35.0 times sine of 45. And it is okay to get the same answer because remember, 45 degrees is perfectly in the middle. So that means your horizontal and vertical are even. Okay, so one's not overpowering the other, so it is okay to get the same answer. And our T total is 24.75 divided by 4.9. And you're going to get a time of 5.05 seconds. Okay, so I'm looking for dx. Okay, so we're going to do our Vx equals dx over t. So 24.75 equals dx over 5.05. And you're going to get a distance of 124.99 meters. Number 3, a player kicks a soccer ball towards a goalkeeper, but at an angle at 37 degrees with the initial speed of 14.7 meters per second. So I gave you the angle, it's 37 degrees. I gave you the hypotenuse is 14.7. We're going to break this into our pieces. So Vx equals 14.7 times cosine of 37. And that's going to give you 11.74 meters per second. VYI is 14.7 times sine of 37. And that's going to give you 8.85 meters per second. Okay, and T total. Take that VYI, so 8.85 divided by 4.9. Okay, and you're going to get 1.81 seconds. Now it says the goalkeeper stands 26 meters from the kicker. Where will the ball land relative to the goalkeeper? So that's not talking about height. It's talking about where is it going to land horizontally. So we're going to see, does it make it to the goalkeeper? Does it go over? Is it short? Okay, so we are looking for dx again. So this is a lot of good practice on finding horizontal distance. So Vx equals dx over t, so 11.74 equals dx over 1.81. Multiply both sides, and you get a value of 21.25 meters. So that's where it landed. The goalkeeper's 26 meters away. So all I would do is 26.0 minus 21.25. And that means it's going to land 4.75 meters. I'm just going to say in front, just to describe it. So it's going to land 4.75 meters short. Okay. So number 4, it says, in problem 3, the goalkeeper watches the ball until it reaches maximum height and then runs at a constant speed to catch the ball just as it reaches the ground. How fast must he run to catch it? Okay, this goalie is running on ground. He's not jumping into the air or anything like that, so this is purely horizontal. So Vx, dx, and t. We're looking for how fast must he go. So Vx is your question mark. Now, we got to figure out what our dx is and what our t is. Now, if he wants to catch the ball, we know that ball is going to land 4.75 meters in front of him. So that's how far he has to go, 4.75 meters. Now, time, be careful with time. I do know the whole time. Okay, that is from launch to where it goes up and then comes back down. Okay, it says the goalkeeper watches the ball until it reaches the maximum height and then he starts running. So it means he waits until it reaches the top and then he starts going. Well, to get to the top is half of your total time. So I'm going to do is I'm going to take that 1.81 and divide it by 2. That means he's got 0.91 seconds to get there. Okay, so we're going to do Vx equals dx over t. So Vx equals 4.75 over t, so 0.91. And that means that that goalie has to run 5.22 meters per second to get there. Okay, next page. A golf ball is driven at an angle of 30 degrees above the horizontal with initial velocity of 60 meters per second. So we're going to go ahead and draw this. So I've got 30 degrees, 60 is your hypotenuse, Vx, Vyi. So we're going to go ahead and do that. So I hope you're starting to see a pattern here. So if you can kind of start doing this every single time, some questions may ask for Vx and Vy and you're just done. Okay, but anything past that, you're going to need those. So Vx is going to be 60 times cosine of 30. And you're going to get 51.96 meters per second. Vyi is going to be 60 times sine of 30. And you're going to get 30 meters per second. It is okay to get whole numbers. It's just going to happen sometimes. T total is going to be that 30 divided by 4.9. And that's going to give you 6.12 seconds. So I've got my 3 things. I'm good. So it says, how high will it rise above the ground? So now we're actually looking for vertical height. So remember, anything vertical is Daffy T. So distance is what you're looking for. A is negative 9.8, always will be. VF, this is where you got to be careful. When you launch something up, it's got to go and go and go and go and go and go until it stops. Okay, so that means your final velocity is going to be 0 now. Now, you got 2 options here. Okay, I always go with the VYI. I already know it, it's 30. I just plug it in. Now, do you know time? Yes, technically. But if you're talking about going to maximum height, okay, this 6.12 right here is the total time. That means from launch all the way till it comes back down to the ground. So if you're going to use a time, it's okay to do that, but you got to make sure you split that in 2. So you'd have to half that, and then you could plug it in here and leave off VI if you wanted to. That's fine, but that's your option. But if you forget to do that step, that can lead to a wrong answer, so just be careful with that. So that's why I always just choose VYI since I already have it. So I'm going to leave off time. Okay, so that's going to mean I'm going to use equation number 5. VF squared equals VI squared plus 2AD. So VF is 0, VI is 30, and that's squared, plus 2 times negative 9.8 times distance. I'm going to do is I'm going to take that 30 squared and move it over to the left side. I'm going to bring this down here so I have more room. Okay, so negative 900 equals negative 19.6d. So I just multiplied 2 and negative 9.8. Now, be careful with this. It does look like it's minusing right here. Okay, that just means it's negative. So just be careful with this. I'm not going to add 19.6 to each side and then get 916 or 919.6 meters. That's not going to be correct. Okay, so what you're going to do is you're going to divide both sides by negative 19.6. So you get a height of 45.92 meters. B, how long will it take to reach the maximum height? Well, you can do Daffy T if you want to, but if you know the time it takes to go the entire way, okay, and you want to know the time it takes to go to the top, well, that's half of it. So all you got to do is just take that 6.12 and divide it by 2, and you're going to get 3.06 seconds. Okay, so you don't have to make that one harder than it is. See how far will it go? Okay, how far will the ball go in the air? Be careful with this. I know it says in the air, so a lot of people assume vertical. Well, we just found height, so you're not going to find it again. Okay, in the air means when you launch that thing, it's in the air as soon as it leaves the ground, and it's in the air the entire time until it comes back down. So it just wants to know how far is this. Okay, so that means we're looking for dx. So your vx, you already know, okay, 51.96 meters per second. Dx is going to be, question mark, and time, be careful with this. I know you just solved for this 3.06 right here, so sometimes people, as soon as they solve that, they think it automatically goes into the next problem. I'm talking about total time, okay, from launch to where it comes back down to the ground, so I'm going to use the whole time, so 6.12 seconds. So Vx equals dx over t, so 51.96 equals dx over 6.12. So multiply both sides by 6.12, and you're going to get 318 meters. There you go. Next one is pick from these angles to answer questions 6, 7, and 8. So I've got a variety from 10 degrees all the way to 90 degrees. Which of these angles should be used if you want to make something go as high as possible? So it's strictly vertical. Okay, if you want something to go as high as possible, your velocity should only be vertical. As soon as you start going down, okay, you start going more into the horizontal range. So that means you're sacrificing vertical velocity to go horizontally. So if I want something to go as high as possible, I'm going to pick the one that goes straight up. That's going to be 90 degrees. Okay, just be careful when you read these problems. I asked for how high it is, so sometimes people, they start reading these questions and they think they know an answer, but that could be an answer for another question, okay? Make sure you're answering the question that I gave you, so make sure you're reading it thoroughly. 7, which of these angles should be used if you want to make something go as far as possible? So I've seen some people, their instincts is, well, if 90 degrees gets me as high as I want to, 10 degrees must get me as far as I want to go to. Now, 10 degrees will have majority of horizontal velocity versus 90 degrees. Okay, so it will have very high horizontal velocity, but it doesn't have enough hang time. Okay, it's going to come back to the ground pretty quickly because it just doesn't get high enough off the ground. If you want something to go as far as possible, remember 45 degrees is the best angle. Pick 2 of these launch angles that will result in the same distance or range. That means you want them to land in the same spot. Okay, easy way to do this is if they add up to 90, they will land in the same spot. So the only two on here that will add up to 90 is 35 and 55. Just be careful with your math on that. So 35 and 55 degrees are the two that will land in the same spot. So 35 will go lower. Okay, it won't have as much hang time. Okay, and 55 will go higher. It will spend more time in the air, but they'll land in the same spot. 9, a cricket ball is driven at 60 meters per second from level ground. What is the maximum range? So there's your dead giveaway what your angle is. So my angle is going to be 45 degrees, and my hypotenuse is 60. So let's go ahead and break it into pieces one more time. So Vx equals 60 times cosine of 45. And you get 42.43 meters per second. Vyi, I'm going to do the same thing. 60 times sine of 45. And you're going to get the same thing. Okay, remember 45 degrees is perfectly in the middle, so they're both going to be the same thing. T total is going to be 42.43 divided by your time. Divided by 4.9. I was jumping ahead to Vx equals dx over t. Okay, so 42.43 divided by 4.9, and you're going to get 8.66 seconds. So remember, Vx equals dx over t. Remember, range is how far horizontal. Okay, so that's our question mark. So Vx is 42.43. Dx, we don't know. Time is 8.66. Okay, multiply both sides, and you're going to get a range of 367.44 meters. Last one. What is the maximum height? Okay, so that means we're looking for vertical. So we're going to set up Daffy T again. So distance question mark. A is negative 9.8. VF is 0 because you got to stop at the top. Remember, I use VYI, so 42.43, and I'm going to leave off time. So that gives you VF squared equals VI squared plus 2AD. Okay, so 0 equals 42.43 squared plus 2 times negative 9.8 times D. So I'm going to square that 42.43 and bring it up, go ahead and bring it over, and it becomes negative. So negative 1800.3 equals negative 19.6 D. Okay, so I'm going to divide both sides by negative 19.6, and you're going to get a distance or a height of 91.85 meters. And that'll end that one.